So what have we done so far? We have derived some axiomatic equations, and from those axiomatic equations, we want to derive our kinematic equations. So we have velocity, okay, and now we'll just refer to velocity as the average velocity in general, equals to some delta, and let's just use x, delta x over delta t. This is going to be equation number one. I'm just going to expand this a little bit to say that this is x sub f minus x initial, okay, divided by t sub f minus t initial. Now, I want to further, I want to just say this, and I don't want to imply, but instead of us using tf minus t initial, let's always take that t initial is just going to be 0, which implies that our tf minus t initial will just equal to tf. But instead of writing t final, let's let t final equal to just t. Thus, our, that's not how you write thus, that implies. Therefore, we're going to write v average in the x direction. It's just going to equal to our final position minus our initial position of some object that is moving divided by t. We're going to call this equation number one. If we had to have an example of that, say we have an object right here, we would have some x initial measured from some location. It could actually be this location. It could be 0, or it could be some location back here, which is defined as 0, 0. So we have our initial x. Then let's say that this object is moved to this location. And now at this point, you have some final x. And our final x is just the length of this vector plus its direction. But we also can put it right here. And you know we can label it like that, just given our ordered pairs. And so our displacement will be between this point and this point. And it's just another vector, delta x. I'm writing small like I don't have room. Delta x. So therefore, this is where we get our delta x equals to xf minus x initial. Now we can do the same thing for time, okay? And with time, we'll have some t initial and some t final, all right? And so we can measure time from some beginning point. Let's say it's 12 midnight. And then we're going to measure time to some final point. Say it's 8:30 in the morning, okay? Or you know, just some later time. And now we're going to have this change in time here. And this is just delta t. And delta t is tf minus t initial. But in our case, if we always say that the initial time is 0, let's just say we're using a stopwatch, and then our final time is t. Now we can write this equation as t minus 0, which is just t, thus resulting in our average velocity in the x direction equaling to our final position minus our initial position divided by the time that it takes for this event to occur. All right, all of these are measurable quantities. We're going to call this equation number one, and it will be very valuable. Okay, so that's our equation number one. First axiomatic, that's the first axiomatic equation that we're going to use to derive our kinematic equations. So let's pull up the next one, or let's come up with a new one. So we're going to look at the average velocity again in the x direction. And this is just going to equal to our initial velocity in the x direction plus our final velocity in the x direction. Both of these are vectors, and we are just going to divide this by 2. Okay, so if we know our initial velocity, we know our final velocity, we just divide it by 2. This is going to be our second axiomatic equation. All right, that's our second axiomatic equation. The third axiomatic equation is going to be as follows. It's going to be the acceleration in the x direction, and we're going to, I could call it average acceleration, but we typically refer to it as constant acceleration. They are the same, okay, in this particular case. In other words, we don't want acceleration to change. We want constant acceleration. So that's what these equations that we're going to derive only work with constant acceleration for our purposes. So in other words, I don't know that they don't work with moving acceleration. They could. You know, I'm sure that they probably can, but we most likely won't be able to get the same predictions. Okay, so let's stick with the constant acceleration. So we're going to have our final velocity minus our initial velocity in some direction. In this particular case, we're saying x divided by t. This is going to be equation number 3. This is our third axiomatic equation. And we'll use these 3 equations to actually derive our kinematic equation. So in the next film, we're going to derive the kinematic equations.